Good morning and welcome to AP Statistics for Thursday, September 10th. What we're going to cover today is the beginnings of Chapter 1. I've decided that we're going to take the Chapter 4 content that we did for summer work. We're going to put it on hold. Do not lose those flashcards or the Quizlet if you made one, because this is a topic we're going to return to, not just in Chapter 4, but sprinkled throughout the year, okay? So looking at Chapter 1 is called Exploring Data. And I'm going to put some words up on the board, but I'm not going to write everything down because I'm hoping you will be taking some notes. We're going to cover some vocabulary right now, and part of the vocabulary touches on the things that we did already in the Chapter 4 summer work. So keep that in mind. First thing we're going to talk about is when we're looking at any kind of study, we need to identify what we're looking at. And individuals is a word that helps us identify that, okay? The definition of individuals is essentially what our data is describing. So if I decide to take a survey on the color of car in the parking lot, the individuals are what we're describing. So cars. So I have a collection of car color data. The individuals being described are the cars. The word variables, obviously a word you've heard before in algebra. It's not quite the same though. In algebra, a variable is an unknown quantity. We call it x, and then we try to solve for it. In statistics, that's not the case. A variable is pretty much any characteristic, and there can be one in a problem, there could be dozens of variables in a problem. So for instance, if I'm talking about cars, variables can be the color, also the age, the type of car, a coupe, a sedan, SUV, a truck, a convertible. We could talk about how much mileage it has on it. We could talk about the age of the tires. There's so many different variables when considering the broad individual of car. So we always want to narrow down what our variables are. So if I'm only interested in the distribution of colors of car, color is my only variable that I really care about in that instance. While we're here, why don't we actually use that word that I just used, which was distribution. A distribution is oftentimes a kind of graph or a chart, or this could be language also, that describes the breakdown of our individuals based on variables. So in my description of color of car, the distribution could also be broken down further by other variables like color and car type, and we can see how they compare to each other. Or I can compare pretty much anything I want, but a distribution of just color could appear as a graph, like a bar chart, where you see the height of a column indicated by the frequency with which a car had that color. That's what a distribution is. It's how our data breaks down, usually a visual tool to further analyze our data. What kind of data can there be? Well, there's two general kinds of variables. We call them categorical and we call them quantitative. Categorical is sometimes also called qualitative. Okay, so what is a qualitative variable, or qualitative data type, I should say? Well, just like it sounds, it's a quality. So you know how I was talking about the color of the car. Color is a qualitative, therefore categorical point of data. It is descriptive, but it has no numerical value. Keep that in mind. Numerical value is important. Sometimes categorical variables can be numbers, but they're numbers that don't have value. For instance, think of the state of Connecticut. If I just took a random sample at a local mall and I asked them what their area code, no, let's go with zip code, what their zip code was, because there's a lot more zip codes than area codes. Like Shelton, 06484, Oxford's 06478, Seymour's 06483, Wilton's 06897. There's a lot of different numbers out there that indicate a point of data, in this case categorical, because those numbers have no actual value. They're just descriptors on a map. Keep that in mind as well. The other one, quantitative, are meaningful numbers that are descriptors of a set of data. So if I survey people's age instead of their zip code, that's a meaningful value. That number can be averaged, it can be sorted, it can be ranked. There's value in that number, more so than in the number like a zip code, or in that case also a phone number. There's no meaningful value in a phone number, save for the area code placing you in a certain region. All right, so that covers those 5 so far. The next up is what we talk about with inference. Inference is actually a major portion of the statistics curriculum, and we get to it towards the latter part of the year. But inference in general means taking data, taking sample results, and trying to understand what it means about our broad population. The population is everyone that fits into the individual category. So whatever the individual is, the broad everyone category is the population. The sample, of course, is the subset of that population. So inference tells me that I can say what my results mean. If I take a sample of, let's say, the ages of people at a local mall on a certain day at a certain time, the inference I can draw is that whatever I find as my data is the breakdown of the age groups that will go to the mall at that time. So if I find that a large portion of the people at the mall at 10 a.m. on a Wednesday are older, let's say over 60, it makes logical sense that the population of over 60 people are more likely to attend the mall at 10 a.m. than is someone who is of a younger age, a worker, a student, things like that. Okay, what does replication mean? Replication means that if I conduct a study or a survey or an experiment of any kind, and I find a result, replication tells me that I can repeat the experiment, the survey, the study in the same way and get the same or very similar results. If I were to repeat my experiment and get different results, we'd say that our experiment does not have replication, and therefore our findings, they're not really valid because I couldn't do it the same way and get the same results. Think of the current trials again for vaccines for coronavirus. After they get a result, good, bad, or indifferent, they have to repeat it, otherwise who knows if it was a fluke. They have to be able to get reliable, repeatable results. And then, of course, we get to what's called variability. Speaking about getting reliable, repeatable results, variability is what we call the differences between sample results when I do a replication. There's variability if I do sampling of various groups and I get some difference in my results. It's expected to get some sampling variability. What you don't want is so much sampling variability that you think it is indicative of total invalidity in our results. We can't trust it. I get a different result every time I do a sampling. So how could I possibly trust this, whatever we're doing? I can't rely on it getting the same results. Okay, now that brings us to descriptive displays of data. Okay, now what does it mean? It means charts and graphs and things that will show you what the data shows you without having to necessarily read all the details. So obviously we've all seen charts and graphs. We're all familiar with how to make some of them. Some things we've seen: pie charts, bar charts, box plots, dot plots, perhaps histograms, maybe, ogives, probably not yet, stem and leaf plots, pictograms, things to that nature. All of those are descriptive ways to display our data. And we've made them, we've used them, and we can understand them, but now you know what they're called. And that brings us to our, let's say, one of our most useful ways to break down data, and it's called a two-way table. I'm going to show you what a two-way table is, then we're going to try to use it. A two-way table is simply a table of values. Whoops, something just fell. I think it's a book. I think I jumped just now. Anyway, a two-way table is a display of data that shows us in multiple variables what our data shows. I'm going to do an example rather than just describe it. So remember those cars we talked about in the parking lot? We're looking at their color. Now let's take a look at what a two-way table of that might look like. So I'm going to have my type of car and my color of car, and they're going to make basically a matrix of data. So let's say the colors were, there were red, there were blue, there were any other color. Apparently my only interest here was, do you have a red car or a blue car, or is it something else? And I'm breaking it down by the kind of car too. So we have SUVs and sedans, we have trucks, and similarly we have other. Now, I am going to shift what I drew over a little bit because I actually intended to leave a little bit of room to the right there. The reason is, once you look at all your data, generally you want to find out the totals, and that's going to create two other fields. So first I'm going to give you some numbers. I'd like you to copy this down. Put a bracket around here, and we say that we had 15 red SUVs, 21 blue, 52 other. We had, for sedans, 22 red, 18 blue, and 70 other. For the trucks, we had 10 that were red, 11 blue, 40 that were other. And for the other vehicles, there were 8 that were red, 7 that were blue, and 18 that were other. Close that bracket and you've created a two-way table. The natural instinct when you look at this kind of data is hopefully to find out the totals. So we're going to add both vertically and horizontally to find the totals for all color groups and also for all types of cars broken down by color. And we found that we counted 88 SUVs, 110 sedans, 61 trucks, 33 that were other, some variety. And so far as red cars, counting across, we have 55 red cars, we have 57 blue cars, we have 180 of other color cars, and whether you add it vertically or horizontally, you're going to find 292 vehicles counted. This is called a two-way table. The totals here and the totals there, they have a separate name. They're called a marginal distribution, essentially breaking down the data in the margins, all right, to the right side or underneath. From a two-way table, using the marginal distributions and the data within the two-way table, we can do conditional probabilities. So what does that mean? I'm not going to go into it too much because it is essentially another chapter, which we will get to. But here's how we're going to use this. What if you're asked, at this parking lot, chosen at random, what's the probability of finding a red car? Well, red cars account for 55 of the 292 cars. So the probability would be 55 divided by 292. You could reduce that, you could make it a decimal. What if I asked for the probability of finding a sedan? Well, there were 110 sedans out of the 292 cars in the parking lot. Again, it could be reduced, turned into a decimal, what have you. A different type of conditional probability would be this. What if I found a red car, given that I found a truck? Well, specifying that I found a truck tells you that we're only looking at these 61 vehicles. And of the 61 vehicles, 10 of them are trucks. So 10 divided by 61 would be the conditional probability of finding a red vehicle, given it was a truck. Let's flip it. What's the probability of finding a truck given I found a red vehicle? Well, now it's not this column that is the condition. It is the condition of being red. Finding a truck given I found a red vehicle is 10 trucks out of 55 red vehicles. It changes the answer. So it is important, the order in which the information is being given to you. Today, that is the extent of the work I'd like you to keep in mind. The homework is this, all right? And I will have already posted this on the classroom as well. Page 21 in your textbook, numbers 13 through 15, 21 through 23, 27 through 30. There isn't that much to do amongst those questions, which is why I gave you that many. I wouldn't give you that much if they were very long problems. That is it for today. Please do that work and have it for tomorrow. Hopefully there's no problems with having the book or doing the work, but if you have any issues, give me an email and I will gladly help you out. All right, have a great day.